Hey folks, welcome to this video where we're going to take a look at some easy decompiling options. Now I am starting to lose my voice, so I hope that I'm still clear. But before we talk about decompiling, let's just understand the process a little bit. When you have a Java file, that's a file that ends in .java, like this one here. I can prove that it ends in .java by just showing you the file view. If I just show you this window here, you can see that on the file system, that's abc.java. It just hides it in the IDE, okay? So when you have a .java file, it needs to be compiled before it can be run. And that's because Java is a compiled language. Now this compilation is done with the Java C tool. So let's give that a try. We'll just come down to the terminal here and say Java C, and we'll give it the file path. Okay, and you can see that that's created a .class file there. Okay, now let's take a look at what that file looks like if we open it up in a text editor, in this case Sublime. You can see that that output is not massively useful. It's a bunch of binary data that we can't really interpret. Now let's try another way of looking at that contents. Let's say cat class, and let's look at this with the cat command. Okay, you can see that that looks a bit more like code, but there's lots of garbage, gibberish characters in there because it's a binary file. So again, not very useful in terms of actual utility. Okay, now let's try a different way of looking at this file. Let's use a command such as xsd that can do like hex interpretation of the binary data. So we'll say xsd source. Now, this looks like binary data similar to what we saw in the text editor, which you can see here with some additional stuff here on the right. If I scroll up, you can start to see some code here. Now, again, this isn't really human readable. It's not particularly useful for a human to view. So let's try something else. Let's just open this class file in IntelliJ. Okay, and now all of a sudden, this looks a lot more like real code. It looks a lot more like the original code that we wrote. If I just open this to the right, so you can compare, this is the code that we wrote, and this is the code that we've opened here, the .class file. Now, this isn't really the contents of the .class file, which is actually bytecode, which looks more like this. This is actually decompiled, okay? So IntelliJ has actually decompiled this code to make it human readable, and it tells you a lot more. All right, so before we go much further, let's go through a few definitions, okay, so we understand what we're talking about. So let me just put a comment here. Okay, so the first thing that we want to understand is bytecode. So this is the contents of the .class file. It's binary data that looks like gibberish, which you can see at the bottom of the screen here, okay? It's not really designed to be understood by humans. It's instructions for Java, okay, how to execute that code. The next thing we have is the let's say the output from tools that interpret the bytecode. Okay, and I'll show you some examples of that shortly. The last thing we have is decompiled code. Okay, so these are three things to understand before we continue so we know what we're talking about. So bytecode, here's an example here of bytecode, which is the contents of the .class file. Output from tools that interpret bytecode, we're going to look at shortly. And decompiled code is what you were looking at when you looked at this. And that's when some sort of decompiler, in this case, Fernflower, which is what IntelliJ uses under the hood, actually tries to reconstitute the code, okay, by looking at the bytecode. So it reads this bytecode and says what the code would have looked like that produced this bytecode, okay? But we'll come back to that shortly. Now, just coming back to decompiled code, decompiling code can be very useful when you are working with code that you don't own. So you don't have the source code for it, okay? You've just got the binaries. You've got a jar file, or you've just got some library code, and you actually want to see under the hood, it's code that you're interacting with, but you can't figure out what it's doing or why it's doing certain things. You might actually want to look at the code, and you can do that by using a decompiler to decompile the code. So that's what decompiled code is useful for. All right, so all of these things come into play when you have a .class file. Now, what if we want to look at the bytecode or decompiled code for a Java file? So forget the class file. Let me delete that, in fact. Okay, and in fact, we already get a default one here, which the IDE generates. That was just one that I generated using Java C. So we get rid of that one. Okay, so here we've got a .java class. Now, if I want to get from this to the bytecode or decompiled code, is that in fact useful? Yes, it is useful. Why is it useful? Well, for learning and improvement purposes. You can get a glimpse under the hood to see what Java is up to when it compiles the code, because the compiler has many, many years of work that's gone into it to optimize the compiled code so that it runs and executes quickly and efficiently. And you can see that it will have undone a lot of syntactic sugar that you might have used. It might have deleted some code that's actually not necessary or redundant. Okay, so let's see how we can do that. So first of all, we've got a Java class here, as we've already mentioned. And now there are a bunch of decompilers and bytecode viewing options that you can use. And we're not going to cover those because they usually require you to download some external tool. And we're just going to look at what's really easy when you've got IntelliJ or when you've just got the Java JDK. All right, so the first thing is, if you've got IntelliJ, then you can just go up to here and say view, and you can say show bytecode, providing that you're looking at a Java class file. And this is the second category of definitions that we were looking at. The first category was bytecode, which is this kind of gubbins down here. And the second category was bytecode that's been interpreted by some sort of tool, in this case, your IDE. Okay. Now, when you're looking at this, it's got lots and lots of information here, which you can look at to understand your code if you need to understand it at that level of depth. You absolutely don't necessarily need this, but it can be useful, as I said, for learning purposes and to understand what's going on under the hood. And it's certainly more useful than looking at this bytecode. Now, the other way of doing this is using the javap tool, which is bundled with the Java JDK. Now, the only thing to keep in mind is that for this, you need to actually compile the code first. So we're just going to go up to here and say build project. It's already built, but I'm just going to rebuild it to make sure it's up to date. And that creates this .class file here, which is in the out directory. Okay, so depending on whether you're using Maven, Gradle, or this is just a default Java project in IntelliJ, you'll have to locate where your .class files are generated by default. In this case, it's in this structure here. All right, so we're just going to say javap, and if we hit tab, it actually finds the only class that's eligible because it looks for class files. And we can execute that, and you get something that looks like this. Now, these are just the method signatures here. You don't get much more information than that because you have to specify certain parameters to the javap process. Now, there's loads of parameters. You can look into them and have a play to see what you need to get exactly the information you want. But we're going to try the javap -c parameter. Okay, and you can see that that goes into quite a lot of detail. So invoke virtual, invoke special, and it's got kind of field names and string hello, blah, 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 which is stuff that you see here. Now, if you remember when we went up to here and we said view show bytecode, you can see that a lot of this stuff is going to be similar. Invoke virtual, invoke special. This is kind of similar to what you saw here. So javap is something that's introspecting the bytecode and giving you this much more useful information that you can actually read as a human. And that's similar to what show bytecode is doing here. So remember, we said that there's bytecode, there's tools interpreting bytecode, and there's decompiled code. This is not decompiled code. This is a tool that's interpreting the bytecode. And javap here is also a tool that's interpreting the bytecode. Now, there's a lot more options for javap. You can just look at the online documentation and see what they are. But javap-c gives us most of the information that we want. All right. So in this case, we looked at item 2, which is output from tools that interpret the bytecode. Now let's just have a look at something else. If I just open this .class file, this is often the most useful way, which is decompiled code. Now, this is taking the bytecode. So this file contains bytecode, but by default, when I open the class file, it's not showing me the bytecode. It's saying the source code was recreated from a .class file by IntelliJ, and it's using a decompiler called Fernflower. Now, when you look at this code, let's compare this to this code. And we kind of did this earlier, but it wasn't so pretty because it was in the source folder. So let's just split right. And if I close this one. So you can see on the right here, we have our original source code. I didn't declare a constructor here, but you can see that the compiled code contains an instructor because Java by default, if your class doesn't have a constructor, it provides a constructor, okay, a default constructor with no arguments. By the way, this is pretty useless code and it was just written to demonstrate what we're talking about. It's not actual production code or anything like that, or even useful in any way. But you can see here that we did this kind of useless reference assignment, and then we never go on to actually use this. So it's kind of pointless. But the object creation, maybe that's, that could go on to do something behind the scenes. It actually creates an object. So that's not useless. But this part here is actually useless because we don't go on to then do anything with my map. Now, if you look at the compiled code, it's actually removed that piece of code because it wasn't actually needed. So when the decompiler decompiles the code, it has no idea that this was there in the original because it's been removed. So here you can see the actual compiler optimized code, and it can often be really useful to look at this type of code. But it is nice to know that you can easily get access to the bytecode in your IDE by just saying show bytecode. And if this extra information is useful to you, then that's quite handy. Also, as we said, you can use javap -c and the name of your class file to get that information from there. By the way, if you don't want to miss out on more useful tech content like programming tutorials, developer news, software company profiles, etc., then don't forget to hit subscribe so that you're notified when similar videos come out. And if you want to signal to YouTube that this video is actually useful, the best way to do that is by hitting the like button. That will tell YouTube that it's actually useful content. All right, so to conclude, in this video, we said that .java files are compiled to .class files. These files, the .class files, contain bytecode. Bytecode is not easily readable by humans, but bytecode interpreters like javap and IntelliJ's show bytecode option show the instructions which can be useful to humans. Decompilers take the bytecode and try to piece together the original code, or at least the code that they can piece together from the compiled code. However, they will include compiler optimizations since they only have the compiled code to work from. I showed you that you can see the bytecode with javap or show bytecode in IntelliJ. You can also decompile code in IntelliJ by just opening the .class file. All right, so let me know in the comments below if you thought that was useful or if there's anything else that you'd like to know. And thank you for watching.